today is February 14th, and this is probably our work. We didn't even know which session is this, but we started this Ull Spark session back in October 2024, and the motive is that we gather together every Friday and then share whatever we are learning in our own field. So as probably you guys already know, I'm a computer science student, currently in my master's degree, and I'm gonna share whatever I learned this week. So there are a few things I wanna highlight. So the first thing I'll talk about is basically maybe data structure that I was learning this week. And second thing I was kind of looking into this week was SSR versus CSR. Do you know what CSR is?
Customer service representative.
Okay, we'll talk about that. So this is something I was looking at this week, and another thing I was looking at is so this also comes into the category of data structure, but I will say how to use data structure to reduce development time. And I don't even basically I was just researching for this stage, but let me start with the data structure. So this week what I learned was mainly graph data structure. Why is it useful? So graph data structure, what I found out was that it's the most practical and most versatile data structure to basically model any kind of relationship in the real world. So for example, Jose and myself, we are a student, right? We are a student, and if I want to track basically how many classes we have in common, maybe that's one application where we can use graph, where Jose is a node and Prasan Basan is a node, and we can maybe traverse how many classes we are taking together to get into each other node. So that's maybe one of the practical application. And another application is maybe we can see how many common classes we are taking. And that could be another traversal algorithm that we can use the graph. So that's about the data structure. Why am I learning this data structure is because, first of all, I started to practice like more competitive programming to solve more problems and better my own problem solving skill. And during which I started from the string, then I started with the array, and then came 2D array, then came tree, then came graph data structure. Then came graph data structure, and this is where I am right now, graph data structure. And some of the questions that I solved during practicing this graph data structure is one was given a 2D array where you have, let's say, a tracer which is represented by 0, and then a water represented by 1. And then let's say you have a land represented by minus infinity, or we can just say infinity number, right? You don't have to say minus infinity. And so this is like this. So there's a water, and then there's infinity, and then this infinity, and then this more water, and here let's say we have another tracer, and we have a infinity which is basically a land, and infinity, and then let's say more water here, which is 1.
So we can only go through one.
So one of the problem was basically this. We are given this array, which is 2D array, and we can only traverse through infinity. Basically, infinity is a land that is connected to each other, and 1 represents a water, 0 represents a treasury. And if you want to find this treasury, how many steps it will take from each of this land to get into this treasury. For example, from here, it will just take 1 step. From here, it will take 1 plus 1, 2. From here, it will take 3. And we cannot go to the water. We cannot go through the water. We have to find another treasury spot. Then from here, it takes 1 step. From here, it takes 2. Here, it takes 3. And so this was one of the problems. And what I reflected was, the reflection was basically a 2D array can also represent a graph data structure. It doesn't have to be a node like this. It doesn't have to be a tree. So normally what we have seen is maybe graph is something like this, and then you have something connected, and then you have another thing connected, then you have another thing connected. This can be also a graph, whereas this also can be a graph data structure. And as I said, to model many kind of relations, for example, Facebook friend, for example, LinkedIn network, right? What's the connection that you have with, like, there's a first degree connection, second degree connection, third degree connection. How close are you from this node to this node? If Ajay and I am connected, then we are mutual friend. If there's someone, basically, let's say this is someone who, Ajay and I have a mutual friend, and this is Ajay node, and then basically this is a first degree connection, and all this is our application of graph data structure. So this is one thing I learned this week. Now let's get into the second topic, which is SSR plus CSR, SSR versus CSR. So now this one falls in this category of data structure, how experienced of a programmer you are, how good enough you are with the data structure. And the more you become efficient, the more you become literally, what is that? The more experience you have with the data structure, the more scalable code you can write. For example, I'll be able to write, anyone who knows how to program can write a line of code, can write an application from that, and this application can be used with tens of people, hundreds of people, and can be even maybe thousands of people, right? But if this app needs to serve, like Facebook needs to serve millions and billions of customers, like 1 million and billions of customers, then this is where, if you don't know data structure, you will never be able to scale your app in a level way. It will be able to serve millions of people, and that's where you need data structure, right? And that's why this is very important for any programmer. And this is also a difference between an amateur programmer versus a really efficient, experienced senior developer. Now let's look into SSR versus CSR. What is so now this falls under the category of development. Let's say we are developing a website and it's just accessed by 10 people. We don't care if it's just being accessed by 100 people. Still, it won't matter. But for thousands, it starts to click. But when we are solving a scale where millions of people are accessing our application, the first thing we need to make sure is it's very fast, because the moment your app starts taking, let's say, more than 5 seconds, the chances are you might just cross the browser, or you might just go to a different link, right? When you're Googling something, and if you click on a link and it takes 5 seconds, 10 seconds, then chances are you're probably gonna cross that browser out and start clicking on the second and third link, right? So this is where the SSR and CSR matter. What does the SSR means? SSR means server side rendering. Server side rendering. And CSR means client side rendering. And so I think this is very clear. Whenever I'm accessing an app, for example, maybe through TikTok or maybe some YouTube, right? What I'm doing is there is a piece of code my browser downloads, and that code is what becomes a browser. Whenever I access google.com, a piece of code downloads into my computer, and through the Node.js engine, which is basically developed by Google, take this piece of code, which is mainly JavaScript code, and then this piece of code is built on my computer, which is a client-side rendering. Basically, I'm the client who is accessing google.com, and now the piece of code is downloaded on my computer, and that's where I can see google.com, right? The server-side rendering is basically, there is this server, which is Google server. This compiles the piece of code that I wrote or Google wrote, and then this directly sends me an HTML page, HTML CSS page, which is a web page, right? And now what happens, the difference is basically, if I download a piece of code, which is, for example, let's say the size of the code itself is let's say 2 MB, right? Or let's say 5 MB for an example. It's an equivalent to downloading a song. So whenever I'm downloading a song, I'll have to wait at least 3-4 seconds. if the internet is good, if the internet is fast enough. But think about if you are in a 3G network and you have to download a 5 MB song, it will take what, 30 seconds? 30 seconds, 40 seconds, 30 seconds, 40 seconds, right? Or more than that. And in this case, if I am accessing an application which takes 30 seconds to run, the chances are I'm not gonna even use it, right? I'm just gonna skip it. And so this is where client side and server side matters. For us to have a blazing fast application which serves literally in a real time, we need to have our code compiled with the CSR, and that's what the advantage Next.js and this Astro.js plays in this fast-paced software development environment.
Basically, some part of code is rendered on the client side, so client does the work of server. That's
the CSR.
That's CSR, right?
So if I have a piece of code, basically the production build for my React app, and normally this is what happens in the React app. When the browser, when the client in the browser comes and write www.az.com or whatever, and that piece of code you compile using React, you use React to develop it, is downloaded on my computer, and that's where I can see your app. And now another approach is, instead of compiling it on my computer, you compile it on your server, and then whenever I type az.com, you send the compiled web page to me, which is already HTML and CSS. And since JavaScript is more advanced than HTML and CSS, well, I mean, it doesn't have to be necessarily advanced, but the fundamental of browser is basically it serves you a web page. It doesn't have to do extra work with it. It compiles the JavaScript code, then produces HTML and CSS. So all that process is cut in half, and now you just need to sort. So basically, SSR is way faster than CSR. And another advantage that we get from the server-side rendering is basically the SEO is done out of the box. For example, how SEO works in Google is basically Google goes through billions and billions of websites, right? Goes through billions and billions of websites, and if the code is not web based, if it's a CSS based, if it's a CSS basically files, then it has to enter this into the queue of SEO, and which it will compile later on. It will not check this SEO right away because this part of code, the JS, needs to be compiled in order to see the web page. And so that's why the CSR side are very low on SEO index. And sometimes, like if I don't know if you have done it, bro, what happens is if you take your React app, and then what React app does is basically the whenever it's loaded for the first time, it literally it's just the DOM code, basically DOM, and there is no web page at all. What this JS code through React app does is basically it takes that code and insert into this DOM to make it an actual application. So there is no application when Google or other SEO search engine tries to first access your application. There is nothing there. So what it has to do is it has to take this piece of code and put it in the queue to later come and then visit and see what it is doing. So that's why when your application, for example, let's say your question and answer, like a forum group discussion forum is built on React.js, what happens is even the question that is being asked in the group might not be found in the Google, because when Google tries and come to your website, it sees the JS code. It does not see the question and answer being, let's say, there is some description about like what is Nepal or where is Nepal, right? And that question is yet not formed in this CSR rendering because there's simply nothing there. It has to take this piece of JS, then put it, then like call an API or something, and then finally use the question and answer, which is another takes another processing right here. But with the SSR server side SSR with the client side rendering, what happens is you don't have this web page.
With server side.
Yeah, with server side, where server does it. Server takes this piece of JavaScript code, then it builds something, right? It take this JS code.
So which is the newer type of rendering? Like which came first?
I mean, if you just have HTML and CSS, then it's automatically a server-side rendering. There's nothing dynamic. But that's called like.
But isn't client-side rendering a part of like latest technology?
Yeah, it's part of the latest technology.
Latest technology, right? Because server-side was always there.
Yeah, if you just take the HTML and CSS, now it becomes a server-side anyways, because the server just serves this file. The complexity was when you start to make this whole process dynamic, you have to have JavaScript, right?
So you said server side is faster, right?
Yeah, server side is normally
So why
faster.
use client side? Why would anyone use client side rendering? What's the benefit of it?
Uh, so if you just start a React project, and if you don't use anything, if you simply use a React library, it's a client side rendering, and
So isn't it faster? I think client side is faster than
so the, I think it has to tailor to the requirement of the application. For example, if you have a corporate application which just employee are gonna use it, and it doesn't need any SEO optimization because nobody in the internet you don't want to serve it to anyone in the internet, right? In that case, yes, client side would be a solution, right? But if you have a discussion forum where you post question and answer, and then you want somebody on the internet to actually see the answer for that question, then at that time you want to find it from somewhere. In that case, you don't want to you don't just want a client side rendering because the SEO on client side rendering is very low compared to SSR. But still, every application out there which is just using a React library is a client side rendering. And just for this specific reason, why the SEO were low, and sometimes you have to compile the code to HTML and CSS, and then show it to your web browser. That time, even the web vitals like first contentful paint, basically the time it took to show you a page in the browser, right? First contentful paint or something like that. And all those are very all those factors that are considered for the web vitals report is very low on client side rendering. And so the moment you use server side rendering, it's fast. But the challenge is again that client side rendering and server side rendering has its own, the professor said, for every solution there is a problem. For every problem there is a solution. If you try to solve a solution problem, you're again the solution you came up with, that has a problem.
There's a trade-off always.
So normally, why don't you just use a SSR, right? Then
Yeah.
the problem is that now this is a static page. Now let's say there is our JavaScript code, right?
I got it.
And there is a JavaScript code. Sorry, there is a app. Let's say I post an application and post something, then you post it as I post it. Now let's say Roxanne post something. Now, the moment I do the SSR, which is basically done in the production build, what happens is, now at this time I do a production build, right? And then what happens is, anyone in the internet now, if you try to access this application, will only see these 3 posts. But if Anurag bro comes and posts again, nobody is going to see on that post because this is now static. We'll have to do another production build for SSR at this point. Which is basically SSR nothing but a pre-rendering, right? And this is the trade-off. With client side, you will see a real-time whoever posts, because it's again JavaScript, right? It does whenever user loads the app in the browser. So at that moment, no matter how many people come in here, right? Everything will be shown in the CSR, but in the SSR, the time before, the only things that were done there before the production build is not in the SSR. That's the trade-off. Okay, bro? Okay, nice. Now let's come on to the third point. I took already a lot of time.
Is it time-lapse or?
No, video.
Video?
Yes.
Okay.
Okay, now we'll come to this third point, how to use data structure to reduce development time. Like, you have any idea what this means?
Data structure to reduce development time, like in software development time. Oh. I don't know, man. You explain.
No, this is just a hypothesis. This is the algorithm that I'm working on right now. So for example, let's say, okay, I'll give you a real example. We have this Unisana, right? Unisana.com. And where you can make a post. Let's say, Azay made something post, right? And now, for this feature, there could be like create a post, edit a post, delete a post, right? DELETE. delete a post, right? All these things you need to do for your application to work. Normally these are very like must-have feature requirements. So for this application, now I have this create a post. Let's say now let's say we're making this edit post. For example, Ajay make a post and he wants to make some changes in his post. Now what you need to do is you need to write an API for edit post. Basically, edit post API. Then before that, maybe database schema, which is universal schema. Then you write a post, and after you have this, you make a feature in the front end to consume the service, right? And now what you do is you put a button, let's say here, edit button, and user needs to click this button. Then the page will go to, let's say, /edit page, and then here's the populating like whatever you wrote before, and then here's the submit button, right? So just to have this edit feature, you already have this create feature. Now you have just for this edit feature, you have to write the whole API, then again come to the front end, add button, and once the button is pressed, you take it to the different route, and then you let them edit, and then once it's edited, you hit the submit button. There's so many flows, right? Think about this is one feature. Normally, like an app will have so many different features, right? So my hypothesis is, can we use our data structure to reduce the development time? Meaning, like next time when the user clicks on edit button, I don't write a code when I don't write. I think there's this functional programming does. It says either use space. You just tell a computer what to do. You don't tell computer how to do it, right? It's the whole philosophy. I forgot the term, but so my assumption, my hypothesis is, can we write it in a node? For example, if somebody click on a node called edit, what you do is you have different keys, like where you want to take, like route key, and the API key, the validation key, everything in a node. And if somebody click on an edit button, the graph traversal will itself now look at this edit and then what the feature needs to be done. And the front will operate on the graph traversal. And so now when you click a edit button, what happens is you will be taken to this side. Everything will be populated, not by hard coding, not by like you specify computer once this edit is clicked, you do this, you do that. But what you do is you have a node, everything is coming from the API. Like maybe even you can space it like what API to it, and everything you have in a node. And so once I click on this node, now computer triggers this function. It doesn't have to be function, it maybe just takes where next route has to be. And so it takes user to a next route, and now we are in a different node. Here maybe this has what is this editor or something like that. And this editor node has a submit, like where to put it, where the validation logic itself. And now when the user click on this button, now you don't have to write any code. Now the graph traversal will now check this node and then just have a flow. So this way, instead of writing every like little bit of tiny to like crazy logical, like from trivial to basically what I'm gonna say is, you don't have to write every single detail as a programmer. All you need to do is use this data structure library, maybe we call it through NPM. And I'm thinking about it. I haven't written it yet, just because it's a pain point of developing a software. And again, it comes like maintainability, scalability, code simplicity. And whereas if we be able to use this, if it really works, then you can see the benefit, right?
I don't see like the benefit of using, because in normal flow, like let's say in the normal flow, even in the normal flow you can click edit and then it takes you to the edit button and you just submit, right? So what does it reduce? What time does it reduce? Because even though if you make a node, then even in the node you have to tell the node what to do, right?
Right.
So how does it reduce the time?
So instead of writing whole code, let's take an example, right?
You can just make a common function and then reuse, like inheritance, right? Just use the base function and then inherit it. It's like it's like inheritance in a sense, but in the node form.
Yeah, but the thing is, even the attribute in the inheritance, whatever you want to do in the class, needs to be different for every single thing. and you have to have like different validation logic, use state logic, so many different logic, even the input form itself, how many buttons you wanna have, everything you need to write by yourself, right? And this is not a problem for like everyone, but this is mainly a problem for like a developer who is trying to build something and doesn't have a lot of people working, right? And,
So you just want to reuse what you have built for one node and just reuse.
no, not one node. So think about it like instead of you writing a code for every single feature, you write a metadata. And
Like
now
an abstract class.
doesn't have to be an abstract class. For example, it's like you say if it's a edit node has this feature which is called API, and if it's the case, then you will say /edit /post, something like this. And validation logic, you write maybe some either you can stringify, but let's not get into validation because I've never thought about it. But you got the point anyway, right? So maybe the button needs to be blue or something. You don't even program it through the front. You just have a metadata for everything green, and you can say validation and use like a race
And like number of text, it also you give a value there. Like
yeah, and whatever needs to be detailed, right? You can maybe programmatically do it, and you take this metadata, and then here in the front end lies the graph algorithm, right? Based on the is and relationship. Now it will take you to this flow, and now it also knows when you click here, it's a different node. You go and find that node, and basically this will help like solo developer or something like that working on the project.
from metadata to UI.
I just wanna, because this is my pain point. For me to develop a single feature, it takes so many effort. I have to write API, then to consume that API, write a whole front end for that. And even in the front end, once I have this feature to publish a post, I then again have to have a feature to edit a post, right? So it's just too many pain points. And instead, what I can say is, if I have this logic written, what I can say is, in the front end, maybe I'll just have a relationship or something like, let's say aces are relationship, and here maybe you can write edit post, delete post, and something like this feature, and then this node will be taken from here, and based on the relationship, now you give the feature to user. So just trying to reduce the data structure. Again, this one has its own problem, but just brainstorming hypothesis that I was thinking recently. So that's that.
Alright, thank you.
Okay, bro. What do you want to talk about today?
My turn. I will erase this out, okay? Alright, thank you so much, Prasad.
Yes, sir.
I will briefly going through the course. Some part of it would be course things that I learned. Right? That would be from distributed computing. What I learned in that subject. Next would be LeetCode. I will be talking about tree structure that I learned, and third would be CSS stuff that I wanna add something there. Okay. Okay. First one is distributed. So the new thing that I got to know there was if you remember, he asked us question, right? Like, why can't you send a Python dictionary to the server side as a dictionary? Why do you have to convert it in JSON, right? Because we have this JSON loads and JSON dumps function, right? We use them all the time. This is to convert dictionary to JSON and from JSON to dictionary, right?
It's a built-in function in Python.
Yeah. So that's how we do it in Python. So conversion from JSON to dict loads is from JSON to dict, yeah, and from dict to JSON. So I had never thought of why we were doing this, right? That's what he told us, that it's because in Python, like dictionary has its own memory location, right? Its own memory reference or memory location, and transferring that memory location to server does not make sense because the memory location of server has another data, right? So that's, and so what it does is it converts it into a text form, like JSON string, more specifically, and that JSON string can be transferred to the server, which it can know about, right? So that's the one thing. And similarly, the same question was about, let's see, he asked us why, I forgot. It was about the same memory location stuff, like why can't we do this stuff in there, right? So it was basically, yeah, I remember, it was like, why can't we send a list, why can't we call in RPC, right, in remote procedure call, why can't we, I think you answered him as well, you gave him a solution as well, like why can't we convert that reference to a value, right? It was the same reason, like why can't we call a function to the remote the server part with data from the client part. It's because same thing, it references to its own memory location, so we can do that. So it was this about distributed computing. I'll go through tree data structure. The one of the question I was learning was,
So, bro, I have a question regarding this RPC. RPC stands for Remote Procedure Call. And in the socket we were discussing, there was two things. And we were trying to pass this array, reference, pass by reference to this socket. But the client, which is connected to the socket, would have no idea what that reference means. That was the issue.
Yeah.
But does that RPC solve that problem, or like you cannot pass by reference at all?
you cannot pass by reference at all. So what RPC does is it creates a message of itself with a variable type or something like that, and the memory location. It creates a message which is self-contained, so you don't have to rely on the memory reference of the client. It's a self-contained, so if you send it to any other computer, it just knows what to do with it.
So always pass by value.
Yeah. You can't pass by reference.
Maybe, bro, like I don't know if you like understand the concept about how this code system is working.
No.
No, not really.
No, not really.
Because that is interesting too. That's how BitTorrent and everything functions.
Distributed computing, you mean?
Code
It's
system,
a
finger
vast
table.
thing, man.
Finger table. Okay, and please.
I do know about finger table and how this thing work. How does it compute it in log n time? I know all this stuff. Do you know about this?
Yeah, so for example, let's say my phone is connected to this network, your phone is connected, my laptop is connected, and your laptop is connected, right? And now let's say someone joins in the network, and let's say they want to download a movie or something, and we can maybe no more than know, then it will be easy.
1, 2. You will four of it, and you added another one. Like
Yeah,
you
we added
Google
another.
compute added here. Okay.
Okay. Now, what is all this like? How? Let's say I'm gonna download a song. That song lies on one of these computers in the network. And what's up with like lookup table and what is that? The
So
successor?
every node has a finger table. Okay.
Uh-huh.
So what finger table does is it tells where the links are for one. So if it has links for 3 and 4, so it knows about 3 and 4 only. One node only knows about 3 and 4. Similarly, 2 only knows about, let's say, 2 and 4, and 4 knows about 1. So what we do is we start with any node. So let's just start from here, okay? And we want to find a node which has the resource, right? So it can forward its information to those nodes which it has link with. So let's say it has link with this one. So it does not have the data, so it forwards with this, and it looks over its finger table, and then it forwards accordingly. So that's how it works. And why does it work in log n time? Is because each finger table has a reference to the like let's say this node has the data, right? So the entry for the finger table is mostly towards all these nodes that are in this range, but all the information are not present in every node. It's just basically transferring the information like do you have it or do you have it, and then it checks for it, and if it does not have it, it just checks for another node. And let's say if the data is here, then it can transfer it to the another data. So on the surface level, but I don't know about the deep level.
Otherwise, I'll have
I myself created a torrent file. Okay, let's go to the tree structure. I was I was learning about the height balance. Height balance tree. So what's a balanced tree?
Balanced tree is something that is not skewed like a linked list.
Skewed like a linked list. Okay. So let's say there are this number of nodes. Okay. So is this balanced?
Height difference has to be less than 1 in binary tree. And so I think it is.
It is balanced, right? Because the height difference is just 1. So how does it work using DFS and recursion is we start with the bottom and we start going towards the top. So we in every recursion problem there is a base case, and for the base case here it's like if not node then we just return 0, return true and 0. So why do we need two information is because true tells us it's up till this node is balanced and 0 means the height of the tree. So let's start with the null node. Okay, so null node there is not node, right? So this condition is true for this case. So here it will return true and 0, true and 0. Okay, and so in recursion we call the same this function, like if it's called DFS, then we call this function with DFS with root dot left and DFS with the root dot right. Okay, so we just traverse through the nodes and we finally get to the null node. We return true and 0, and then the condition is to add 1 to the max of left and right. Right. So what it does is it adds 0. So since it's one node, right? So the 0 value will be true, comma 1, true, comma 1 for this as well. And again this will be 1 plus 1, so it will be true, comma 2. Okay. Similarly, it will be true, comma 1. And finally, the maximum value is 2, so it will be true, comma 3. So true means it's balanced and the height is 3. So in every recursion problem, what you have to think about is the base case. The base case is this one, and how do you add up the value? Like let's say if the null node is the height is 0, then if you go upwards, then it becomes 1, 2, 3. Okay, so that's what I learned. I'll make it quick. The lastly, CSR. So what I want to add is when I worked professionally in Nepal, I worked in web archiving software.
Nice.
So what it does is you give a domain to the smart web archiving software, and it archives everything, like from JavaScript, from image to HTML content, everything. So it's basically archive, right? And the problem we were facing was with the websites that were client-side rendering.
Nice.
You know the problem? Because let's say this is a page source, right? Page source. If it was server-side rendering, then we would have every content, right?
Yes.
We could just easily archive those, right? But in the CSR websites, it only had like JavaScript code, like the one line code for a full page, right? What do you archive from there? Like, there were no content.
And
So
even the code, whatever the code is referring to, can change in the time.
yeah. So all this dynamic, we call them dynamic pages, and whenever client we used to complain us, we used to say it's a very dynamic web page, so we cannot archive it. So that was a very
Base situation.
very what do you call it?
Frustrating.
Very. It was happening a lot of time. So what do you call it? It was happening a lot.
Most of the time.
Most of the time.
Because I think that's the fundamental architecture how React works.
So when you told me about CSR, then I remember, oh, yeah, we used to see those type of websites a lot, and they were addicted to us.
Yeah.
Because we cannot.
Those are addicted to SEO as well, and that's why they give them like low rankings.
Yeah, okay. CSR website have low ranking.
Yeah, CSR.
Uh,
Because bro, literally, if the like a server does not work, whatever the JavaScript is facing from, it's literally a blank page.
yeah, exactly. So the content that we archived used to be blank, and they were like, "Why is it blank?"
Yeah.
And when you go to the page source, it only has like JavaScript in that.
We're done with our session, guys. So that was it.